Hello, Algebra students. Today we're going to be covering the Unit 2 bookwork. So that's in your packet where you get to basically where you're doing a bunch of bookwork. There's a bunch of empty pages with boxes in them and so forth. You're going to need this textbook, and we're going to go ahead and when you're following along, just try to answer all the questions I ask you to, and the questions I kind of do with you, just kind of write what I write. And for most of the questions, I really want you to write down the question as well. Unless it's a word problem, then you won't have to write those questions. But preferably for the word problems, I want the answers written in a complete sentence, preferably. But besides the word problems, please write down the problem and all your work. I will demonstrate how to do all that and everything. Just kind of copy what I do. Okay, so with that, let's go ahead and get started. I'm going to share my screen here, and let's go ahead and go to, I guess it's on page, let's see, page 35. And, that's what I want, page 35. And we're going to go to page 127 through 129 in the textbook. So in your textbook, let's go ahead and turn there, 127. And you should see problems, a bunch of problems there. And we're going to do problems 1 through 37, and then 40, 52, 58, and 59. Okay? So let's start with question 1. And a lot of these problems are going to be solving proportions. So this first question has b over 6 equals 4 over 5. So when you're solving a proportion, which a proportion is basically when you have two fractions with an equal sign in between them, what you want to do is cross multiply. So 5 times b is 5b. By the way, whenever you write a number right up against a variable like this, that means these two things are multiplied. All right. And that's generally speaking, whenever you have two things next to each other like that, they're trying to say that those two things are multiplied. So whenever you see 5b or 7x or 18y, that means those numbers are multiplied by those variables. Okay, you may even see like 7xy. That means 7 is multiplied by x and then multiplied by y. So those are all multiplied together. Okay, so cross multiply b times 5 and then 6 times 4. So that's 24. Now to solve for b here, what you want to do that is, well, like I said, this means these are multiplied, 5 times b. So to cancel out multiplication, you use division. So we're going to divide by 5 to cancel it out. Divide by 5 on the right side as well. That'll give you that b equals, and then 24 divided by 5. 4.8. Okay, 4.8. And you're welcome to use a calculator throughout this entire course. Let's try another example. Question 2 says 5 over 9 equals 15 over x. Okay, so let's cross multiply. So 5 times x is 5x. And then 9 times 15 is 135. So what would be my next step here? Well, you would divide by 5 on both sides of the equation. That gives you that x equals 27. Okay, so please just copy everything I'm doing so far, and it'll make sense as we continue to go through. Okay, number 3 is where it gets a little more complicated, but it's not too bad. Let's go ahead and do it. So it's w plus 3 over 4 equals, and then we have w over 2. So let's go ahead and cross multiply. So 4 times w is 4w. And then when you do 2 times, you have to do 2 times w plus 3. So 2 times w plus 3. And this is another way we can show multiplication, is by putting a number in front of a parentheses like that. This means 2 times w plus 3. So now what we can do is distribute the 2 to both these in here. So 2 times the w and then 2 times the 3. So that's going to be 2w plus 6. And then on the other side, we still have 4w. Now notice in this case, we have w's on both sides of the equation. Generally, we don't want that. We want to have all of our variables on the same side. So let's go ahead and get rid of these 2w here and subtract 2w here to keep it equal. That'll give you, these cancel here, leaving you a 6. And then here you have 4w minus 2w. That's 2w. Divide by 2. Divide by 2. W equals 3. Now, whenever you get an answer for a variable, you can always plug it back in, and it should give you an equal fraction here. So if you replace both the w's here with 3, it should make an equal statement. Okay, number 4. 3 over x plus 1 equals 1/2. Okay, so very similar to what we just did. Let's cross multiply. 1 times x plus 1 is just x plus 1, right? Anything times 1 is itself. So x plus 1 times 1 is just x plus 1. Then 3 times 2 is 6. Here, to get x by itself, notice it says plus 1. To cancel that, you would subtract 1. That'll leave you with x equals 5. Question 5. A band went to record a recording studio and recorded 4 songs in 3 hours. So they did 4 songs in 3 hours. Notice I did songs over hours. How long will it take the band to record 9 songs if they record at the same rate? So remember, this was 4 songs, 3 hours. So where should I put that 9, right? Because it says they want to record 9 songs. Should I put the 9 on top, or should I put the 9 on bottom? Well, the answer is you should put the 9 on top, because notice this first fraction we did songs over hours. So the second fraction, we also want to do songs over hours. So however you form this first fraction, make sure you form the second fraction in the same way. And x will be the amount of time that they're looking for. So let's go ahead and cross multiply. So 4 times x is 4x equals 3 times 9 is 27. Divide both sides by 4 to get x by itself. That'll give you x equals 27 divided by 4, which is 6.75. So it'll take 6.75 hours. We'll put H for hours. Question 6. Use the proportion m over n equals p over q. And questions 6, 7, and 8, it says find the extremes, find the means, and find and the cross product. Okay, so you may have to look at some vocabulary here in this. Let's see. What does the extremes mean? Well, for question 6, we'll just do the cross product here. So m times q is mq. And so the cross product would be h times p, which is hp. Okay. Whenever you're multiplying 2 variables, you can just put them next to each other like that. And that means they're multiplied. Okay. You can just put this answer for 6, 7, and 8. So just copy that same thing for 6, 7, and 8. That's fine. Okay. Don't worry about the extremes or the means. Don't worry about that. Okay. Question 9. When solving x over 5 equals 3 over 4, Lisa's first step was to write 4x equals 5 times 3. Okay, so Lisa wrote 4x equals 5 times 3. And then it says Jen's first step was to write 20. So Jen, row 20, x over 5 equals 20, 3 over 4. Will both methods work? Explain. So for Lisa's method, how did she get this step? Well, she cross multiplied. You could see that 4 times x and then 5 times 3. For Jen's method, she's multiplying by the lowest common denominator. So for 5 and 4, those two denominators here, the lowest common denominator is 20. So they're multiplying both sides by 20. And that'll cancel out the fraction. Notice if we did the next step of Jen's, so we would do 20 divided by 5, that's 4, then times x. So that's 4x. And then 20 times 3/4, you do 20 divided by 4, that's 5, and then times 3, that's 15. Isn't that the same as what Lisa did? 4x equals 15. So both of these methods will result in the correct answer. So I want you to state that there, that both methods will result in a correct answer. Okay, but mostly we're going to focus on doing things Lisa's way, mainly solving by cross multiplication. But there are times where we want to use this multiplying by the lowest common denominator, and that'll be later on in some of the other units. Okay, question 10. So this one says Q over 8 equals 4 out of 5. So what we're going to do is cross multiply. So that's 5Q equals 4 times 8 is 32. Go ahead and divide both sides by 5 to get Q by itself. That'll give you that Q equals 6.4. You can divide that in your calculator. Okay, question 11. This one says -3 over 4 equals x over 26. Okay, so I want you to see if you can solve this one on your own. So you're going to cross multiply and divide. Okay, I'll give you a hint. Your answer should be negative. Okay, I'm going to let you try number 12 on your own. 13, try on your own. 14, 15, 16, and 17. So do all those. Try to do them on your own, and just put the answer as a decimal. That's fine. Or you could leave the answer as a reduced fraction. That's fine as well. Okay, but just do all the ones up to number 17. Okay. I also think you should be able to do 18. Try that on your own. 19, 20, 21, 22, 22. I'll go ahead and do this one for you because this one has a negative in it, but it doesn't make it any harder. So 22, we have -9 over b equals 5 over 6. So what we're going to do is cross multiply, same as before. So -9 times 6 is -54. Remember, a negative times a positive is negative. Equals 5 times b, which is 5b. Go ahead and divide both sides by 5 to get x by itself. Or sorry, not x, to get b by itself. And this would be, remember, a negative divided by a positive, if they're different signs, that would be negative, right? So negative 10.8 should be your answer there. Okay. Notice we put -10.8 equals b. That's fine. You could put equals the variable, or you could put b equals -10.8. It's the same thing. So you could put the answer equals the variable, or the variable equals the answer. It's the same. Okay. 23, go ahead and try this one on your own. 24, go ahead and try this one on your own. And 25, try this one on your own. Okay. Now, for number 26, we're going to be doing, I'll do some of these with you, but basically there's going to be a little more algebra involved. So for number 26, it says a minus 2 Now, before you get to these, I want you to go ahead and do all the ones before. Okay, so pause the video if you haven't already and do all the ones up to this one. Okay, a minus 2 over 9 equals 2 over 3. So here, same idea. We want to cross multiply. So we can do 3 times a minus 2. So that's going to be 3 and then times a minus 2. We've done one similar to this already, but I'm going to go over a few of these with you. So, and then 9 times 2, which is 18. Go ahead and distribute this 3. So that means this 3 gets multiplied by every term in the parentheses. So that's going to be 3a minus 6. Now what we want to do is get a by itself. Solve for a. So the first thing we want to do is add 6 to both sides. So you see how this is a minus 6? To cancel it, you would need a plus 6. So we add 6. And whatever you do on one side of the equation, you always do on the other side. Okay? So what's left over on the left is 3a equals, and then what's over here is 24. Hopefully you know the last step already. You divide both sides by 3 to get a by itself. A equals 8. (27) b plus 4 over 5 equals 7 over 4. Again, let's cross multiply. So 4 times b plus 4 equals 5 times 7, that's 35. Let's go ahead and distribute this 4. So the 4 multiplies with the b and also with this other 4. So that's going to be 4b plus 16 equals 35. What do you suppose my next step is? Well, I want to get rid of this 16, right? So I'm going to go ahead and subtract 16. So when it says plus 16, I subtract it to cancel. Adding and subtracting are what we call inverse operations. So 35 minus 16, that gives me 19. So on the left side, I've got 4b equals, and then over here, 19. This 4 is multiplied by the b, so to cancel it, we do the opposite. We divide. Divide. That gives you, the 4's cancel, the b equals 4.75. 75, yeah. Okay. Number 28. I think you could probably do number 28 on your own. Go and give it a try. Number 29. It's a little bit different, but I'll show you how to do it. 2c over 11 equals c minus 3 over 4. So notice there's a c on both of these numerators. So when we cross multiply, there's going to be a c on both sides of the equation. So first let's do the 11 times c minus 3. So that's 11. And then parentheses c minus 3. On the other side of the equation, 4 times 2c, that's going to be 8c. Whenever you're multiplying something with a variable times a number, you just multiply the coefficient, right? The 2 times the 4 gives you 8. What do we do next? Well, we distribute this 11. So the 11 gets distributed to everything in the parentheses. So that's going to be 11c minus 33 equals 8c. Now, you notice that there's c's on both sides of the equation. We generally don't like that. We want our c's all together on the same side. So what we're going to do is subtract 8c to both sides of the equation. What's left on the right is now 0, right? Everything canceled on the right, but you'll still put 0 here. Okay, so 11c minus 8c is 3c. Here we still have a minus 33. Okay. Now we need to get c by itself. So what would be my next step? hopefully you see that I would add 33 both sides. Whatever you add to one side of the equation, you always add on the other side of the equation. That'll leave us with 3c on the left equals 33 on the right. Divide by 3 on both sides of the equation to get c by itself. 33 divided by 3 is 11. I want you to go ahead and try number 30 on your own. All right, let's do number 31 together. 3 over 3b plus 4. Okay, this one's getting a little more weird, but not too bad. Equals 2 over b minus 4. Okay, so once again, we're going to cross multiply. So 3 times b minus 4. So that's going to make 3 times b minus 4 on one side of the equation equals, and then cross multiply the other way, 2 times 3b plus 4. Okay, again, I want to emphasize you should be writing down everything I write. It'll definitely make it make more sense in your head if you just copy everything I write. Let's distribute the 3 over here. So it's going to give me 3b minus 12. Again, the 3 multiplies with both of these terms. Distribute the 2 on the right side. So that's going to give me 2 times 3b. Well, that's 6b plus 2 times 4. That's 8. Notice there's b's on both sides of the equation. We don't like that. We want all our b's together on the same side. So what we're going to go ahead and do is subtract 6b over here, canceling that, and we'll subtract 6b on the other side as well. That way we only will have b's on the one side, on the left side. So 3b minus 6b, that's negative 3b. Okay. Minus 12 is still on this side. And then on the right side, all that's left is an 8. To help us get b alone, we're going to add 12 both sides of the equation. Add 12 over here as well. Negative 3b equals 20. Divide both sides by negative 3. That'll give you that b equals negative, remember, negative divided by a positive is negative, 6.67. We'll round to the nearest hundredth. So round to the second decimal place there. Okay. You could also leave it as a fraction. It's already in reduced form. That's fine like that. Okay, 32. This one's similar to 31. So let's go ahead and work on it together. So it's q plus 2 over 5 equals 2q minus 11 over 7. So again, we want to cross multiply. So we're going to do 7 times this q plus 2. So 7 times q plus 2 equals, and then we'll do 5 times 2q minus 11. Both of these sides of the equation, you're going to have to distribute, right? 7 times q, 7 times 2. That's going to give you 7q plus 14 equals, let's distribute this right side, 10q minus 55. There's q's on both sides. We generally don't like that. We're going to go ahead and subtract 10q both sides of the equation. That way we'll only have q's on this left side. So we're going to subtract 10q both sides. Remember, whatever you do to one side of the equal sign, you always do on the other side of the equal sign. So 7q minus 10q, that's negative 3q plus 14. See, there's still a 14 on this side, equals negative 55. There's a negative 55 over here. We're going to help us get q by itself. So we're going to subtract 14 both sides. That'll give us negative 3q on the left equals, and then negative 69 on the right. Divide both sides by negative 3 to help us get q by itself. That'll give us that q equals negative 69 divided by negative 3. Remember, a negative divided by a negative, that gives us a positive, right? Just like a negative times a negative gives us a positive. So that's going to be 23 as our answer, positive. Question 33. This one has c plus 1 over c minus 2 equals 4 over 7, 4/7. When we cross multiply, that's going to give us 7. So 7 times c plus 1, 7 times c plus 1 equals, and then cross multiply the other way, 4 times c minus 2. Hopefully you know by now we're going to distribute here, distribute the 7, giving you 7 times c, that's 7c, plus 7 times 1, which is 7. Here we distribute on the right as well, 4c minus 8. There's c's on both sides of the equation. We generally don't like that. So let's go ahead and subtract the 4c on both sides of the equation. That way we will only have c's on the left side. Here this is negative 8. It's still remaining on the right. Subtract 7 both sides of the equation to help us get c by itself. We cancel out that 7. Negative 8 minus 7 is negative 15, right? This is like you owe me $8 and you owe your friend $7 more. Well, then you would owe 15. To get c by itself, we divide by 3. That'll give us that c equals negative 5. So negative divided by positive is negative. (34). This one's a word problem. So if you can, look at your book and follow along as I read aloud. A gardener is transplanting flowers into a flower bed. She has been working for an hour and has transplanted 14 flowers. She has 35 more flowers to transplant. If she works at the same rate, how many more hours will it take her? So she did 14 flowers in 1 hour, right? But she needs to do 35 more flowers. So would that 35 go on top or on bottom? Well, think about how we wrote this fraction. Flowers over hours. So the next fraction, we also want to do flowers over hours. So it's 35 flowers. That'll go right here. We don't know how many hours that's going to be, so we'll put x here for now. Let's go ahead and cross multiply. 14 times x. And again, x is the number of hours it's going to take. 1 times 35 is 35. Divide both sides by 14. That'll give us x equals 2.5. So it'll take her 2.5 more hours. So I would write this in a complete sentence. It'll take the gardener 2.5 more hours. Number 35. A florist is making centerpieces. He uses 2 dozen roses for every 5 centerpieces. How many dozens of roses are needed to make 20 centerpieces? So 2 dozen roses created 5 centerpieces. So how many roses are needed to make 20 centerpieces? So remember, the top here we wrote, these are the dozen roses. Here are the centerpieces. So on the second fraction, we want to do the same thing. Dozens of roses on top, centerpieces on bottom. So here it says 20 centerpieces. So that's going to be down here. And we don't know how many dozens of roses that's going to be. So we'll just put a variable. I use x, but you could use any variable you like. 5 times x is 5x. Again, cross multiplying. 2 times 20 is 40. Then to get x by itself, we divide by 5. This gives us that x equals 8. So the answer would be that he needs 8 dozen roses for those 20 centerpieces. Make sure to write that in complete sentence. Picnics. If 5 pounds of pasta salad serves 14 people, okay, so 5 pounds of pasta salad serves 14 people. So this is pasta salad over people, okay? Our second fraction, we also need pasta salad over people. How much pasta salad would you need to bring to the picnic for 49 people? So here, the 49 would go on bottom because that's the number of people. Same here. X is the amount of pasta salad needed. Cross multiply. 14x equals 5 times 49 is 245. Divide both sides by 14 to get x by itself. $17.5. So 17 and a half, essentially, 17.5 pounds of pasta salad is needed. 17.5 pounds of pasta salad is needed. 37 is on the next page. More word problems. Number 37. Approximately 3 people out of every 30 people are left-handed. Okay, so 3 people out of 30 people. But these 3 are left-handers. So 3 left-handers out of 30 people. How many left-handed people would you expect in a group of 140? So the 140 are not left-handers, they are the total, okay? So that'll go here. And we don't know how many left-handers that's going to be. Let's go ahead and cross multiply. 30 times x is 30x equals 3 times 140, 420. Divide both sides by 30 to get x by itself. And that's 14. Okay, so we would expect 14 left-handed people. That's what we want to say. We would expect 14 left-handed people. Number 40, video downloads. A particular computer takes 15 minutes to download a 45-minute TV show. Okay, so 15 minutes of downloading for a 45-minute show. So this is downloading show. How long will it take a computer to download a 2-hour movie? So in this case, the 2 hours, I'm going to write that to the side, 2 hours, 2-hour movie. Okay, so that's going to go in the denominator because that's the length of the movie. But notice for this first fraction, it was in minutes, right? This was 45 minutes. So we want to make sure that when we put it down here, we have it in minutes as well. So the 2 hours, when we make that into minutes, that's going to be actually equal to 120 minutes. Okay, so that's going to be 120 we're going to put down here. Because it was minutes over here, we want it minutes over here. Okay, let's go ahead and put x here. And we're going to cross multiply like before. So 45 times x is 45x equals 120 times 15 is 1800. Divide both sides by 45 to get x by itself. That gives us that x equals 40. So it'll take 40 minutes to download that 2-hour movie. That's what you want to say. Number 52. A bakery sells packages of 10 bagels for $3.69. So 10 bagels for $3.69. If the bakery starts selling bagels in packages of 12, how much would you expect a package of 12 to cost? So bagels over cost, bagels, 12 bagels over cost. Okay. If you accidentally have that second fraction flipped, where like if you had bagels over cost here, but here you had cost over bagels, it's not going to work out right. Okay. We want to make sure that whatever item is on the numerator is the same type of item on the numerator here. Same with the denominator. Okay. I'm going to go ahead and let you try to solve that one on your own. So go ahead and finish that one on your own. But I helped you set it up, so that's good. Number 58. 58, this one's probably the hardest one. Parade floats. A group of high school students is making a parade float by stuffing pieces of tissue paper into a wire frame. They use 150 tissues to fill an area that's 3 feet long by 2 feet wide. Okay, so we used 150 tissues. So this is 150 tissues. And the area, it says, was 3 feet long, 2 feet wide. So if we imagine 3 feet long and 2 feet wide, what would be the area of this rectangle? So I don't know if you remember how to find the area of a rectangle, but to find the area of a rectangle, it's length times width. So the area of this rectangle would be 6. So it takes 150 tissues to cover an area of 6 square feet. Then it asks, the total area they want to fill is 8 feet long by 7 feet wide. So the one they want to do is 8 feet by 7 feet. So what would be this area here? Well, the area of this rectangle would be 56. So if it takes 150 tissues to cover 6 square feet, how many tissues are needed to cover 56 square feet? Now, I want you to be able to solve that on your own. I'm pretty sure you can be able to finish it from there. Okay, go ahead and give it a try. And don't forget to answer these word problems in a complete sentence, please. And remember, a complete sentence means you capitalize the first letter and you put a period at the end. Okay, number 59. Insects. It takes an insect 15 seconds to crawl 1 foot. So it could 15 seconds to crawl 1 foot. How many hours would it take for the insect to crawl 1 mile? Okay, so let's first figure out how many seconds it's going to take for the insect to crawl 1 mile. So it takes 15 seconds to crawl 1 foot. A mile is actually 5,280 feet. Okay, so let's go ahead and cross multiply here. 1 times x, well, that's just x because 1 times anything is itself. And 15 times 5,280 is 79,200. Now this is in seconds, right? But it asks how many hours. So if this is the number of seconds, so this is in seconds, I want to change this to hours. So how do I change from seconds to hours? Well, to change from seconds to minutes, we divide by 60. So first we're going to divide by 60, and that'll give us the number of minutes. So this is 1,320 minutes. Now, how do we change from minutes to hours? Well, how many minutes are in an hour? 60 again. So we're going to divide by 60 once again. That'll tell us it'll take 22 hours. Okay. So here we cover a little bit of conversion here, right? From seconds to minutes, minutes to hours, and also from miles to feet in the setup. But yes, it would, at this rate, it would take the insect 22 hours to cover 1 mile, which is very, very slow. Okay, let's move on to the next set of problems. Page 421 and through 422. So when you're ready and you've completed all those, let's go ahead and move on to those pages, 421, 422. And we're going to start with problem number 9 here. Okay. Now this section is mostly to do with exponents. So hopefully you remember all those exponent rules that we covered. But if you don't remember them, that's okay. We're going to go over them. So these say simplify each expression. So the first one is 3 to the power of -2. So remember, when you have a negative power, basically that means it's going to go into the denominator. And once you move it into the denominator, it becomes a positive power. So that becomes 3 to the power of +2. And we'll put a 1 on top. Now, what is 3 to the power of 2? Well, that means 3 times 3. So that's actually 1/9. Because 3 squared, in other words, 3 to the power of 2, is 3 times 3, which is 9. Okay, number 10. I don't think we've covered this rule, but let's go ahead and cover it now. So we have -4.25 to the power of 0. Now, I want to emphasize here that the negative is in the parentheses, which means that this entire thing, including the negative, gets to the power of the exponent. Okay, so if the negative was not in the parentheses, then only the 425 would get the exponent. But since it's in the parentheses and the exponent's outside like that, so everything in the parentheses gets that exponent. So that includes the negative. All right. Now, that being said, anything to the power of 0 is 1. So no matter what number is in here, it doesn't matter. Anything to the power of 0 is 1. Okay. Number 12. So here is where we see the negative not in the parentheses. Okay, on number 12 here. So what does that mean? That means that the negative will not get this exponent. Only the 5 will. So the negative does not need to come into the denominator or anything like that. This negative exponent will put this 5 squared in the denominator. We'll put 1 on top. What is 5 squared? Well, that's 5 times 5, which is 25. Number 13. So here's the example of what about if this were in a parentheses. So what's the difference here? Okay. So again, the negative exponent makes it 1/-4 squared, like that. Remember, once you move it in the denominator, that becomes a positive power. So here, this would be 1/, and this would be like -4 times -4, right? Because it's -4 squared. So that would be +16, right? A negative times a negative is positive. So notice the difference between these two. If you have that negative outside not getting squared, that negative sticks around, doesn't it? But if the negative is getting squared, then that gets multiplied here as well. You can see sometimes it might turn out negative or positive. It's important where you put that as parentheses, right? Okay. 14. 2 to the power of -6. Well, this means 1/2 to the power of 6, which 2 to the power of 6, that means 2 times 2 times 2 times 2 times 2 times 2. So 2, and your calculator should have an exponent. Usually it's like, it'll have like y with an x in the exponent or something like that. Or you might have, so you might see a button on your calculator that looks like y to the x. That means it's an exponent. Or, so this might be a button on your calculator. Or you might see one like this. This is like called a caret, but that's also used for exponents as well. So you can do, on my calculator, I would do 2 to the power of 6. and I get 64. So this would be 1 over 64. I would suggest figuring out how to use your calculator and make sure on your calculator on your own, you should be able to find that 2 to the power of 6 equals 64. Now, if you can't find that button, if you can't figure out how to do that on your calculator, you could always just do 2 times 2 times 2 times 2 times 2 times 2 and get the same answer. But you can see that that takes a lot more time and much more likely to make a mistake as well by putting too many or too few 2's. Okay, question 17. Here we have 1 over 2 to the power of 0. So remember, anything to the power of 0 is 1. So this becomes 1 over 1, which is just 1. (18) 58 to the power of -1. So again, we have a negative exponent here, which means we need to put it in the denominator, and that'll make it a positive exponent. We'll put 1 over that. Anything to the power of 1 is just itself, so we could just write that as 1 over 58. Anything to the power of 1 is just that thing. 19. 1.5 to the power of -2. Again, that makes 1 over 1.5 squared. So 1 over, now 1.5 squared, that means 1.5 times 1.5, which gives you 2.25. So 1 over 2.25. Number 20. Here we have -5 to the power of -3. So this one's a little bit tricky, and I'll show you. And the -5 is in parentheses. So -5 to the power of -3. Now again, we have a negative exponent. So a negative exponent means it needs to come into the denominator, and it'll become a positive exponent. So that's going to be -5 to the positive 3 in the denominator. Just put a 1 on top. So this means 1 over, and this would be -5 times -5 times -5. So should that be positive or should that be negative? Well, imagine if so essentially we have 3 negatives multiplied with each other, right? A negative times a negative times a negative. Well, these first 2 negatives, when they multiply, negative times negative, that makes a positive, doesn't it? But then we have a positive, these make a positive. So then we have a positive times a negative. Okay, what's positive times negative? Well, that should give you a negative on it. So when I have negative to the power of 3, so 3 negatives multiplied together, that'll give me actually a negative. So this gives me negative. And then we want to do 5 to the 3rd power, which is 125. I hope that made sense. Number 37. It's on the next page. Evaluate each expression for r equals -3 and s equals 5. And the first one says r to the power of -3. So, and it says the value of r is -3, right? So for numbers 37 through 44, all of these r equals -3 and s equals 5. So you see that in the instructions on the page. So r will equal -3, and everywhere you see an s, that'll equal 5. Okay, so r to the power of -3, that's the same as saying, remember, r is -3, so that's -3 to the power of -3, which is 1 over -3 to the power of 3, which is 1 over -27. Remember, a negative to the 3rd power is going to still be negative, just like we covered over here, just like with this -5 to the power of 3 here. Okay. 38. Here we have s to the power of -3. So that's the same as saying 5 to the power of -3. I know my s's look like 5s, but nothing I can really do about that. Okay, so this is 1 over 5 to the power of 3, right? Because that negative power puts it in the denominator. 5 to the power of 3, that means 5 times 5 times 5, that's 125. So our answer is 1 over 125. Number 39 says 3r, that means 3 times r, over s to the power of negative 2. Okay, so remember how I said if it's a negative power, that means we put it in the denominator, right? And it will become a positive power. Well, this negative power is already in the denominator, right? See how it's already in the denominator? That means it actually needs to come up to the numerator. So this one's going to come up to the top and then become a positive power. So essentially a negative power, it needs to move where it's at. If it's on top, it'll come on the bottom, then become positive. But if it's a negative power in the denominator, then it needs to move up and become positive. So we can rewrite this now as 3 times r times s to the power of positive 2. Now, once it moves where it's at, it changes to a positive power. R is negative 3 and s is 5. So this will become 3 times negative 3 times 5 squared. So 3 times negative 3. Well, actually, let's go ahead and do the exponent first. I don't know if you remember our order of operations, but we always do our exponents before multiplying. So this would be 3 times negative 3 times 5 squared is 25. And then let's go ahead and multiply these together. 3 times negative 3 is negative 9. Negative 9 times 25 is negative 225. Number 40. Number 40 says s to the power of 0 over r to the power of negative 2. So again, here we have a negative exponent, but it's in the denominator, right? So that means it needs to come up. So this will become s to the power of 0 and then r squared. Well, as we covered before, anything to the power of 0, anything to the power of 0 is 1. So this becomes 1 times r squared, which is just r squared, right? Because this s to the power of 0, doesn't matter what s is, this will become 1. So, and as we discussed, r is negative 3, so this becomes negative 3 squared, which is like this. That means negative 3 times negative 3, a negative times negative, that's positive, positive 9 in this case. 41. 4 times s to the power of negative 1. So here we have a negative exponent here, so that's going to come down into the denominator and then become a positive exponent. The 4 does not move down since it didn't have a negative exponent. It just stays on top. S is 5, so this becomes 4 over 5 to the power of 1. And 5 to the power of 1 is just 5, so we just call this 4 over 5. If you want it as a decimal, this would be 0.8. Okay. Number 51. Write each number as a power of 10 using negative exponents. So number 51 says 1 over 10, which we could write that as 10 to the power of negative 1. These are the same thing, aren't they? Right? Because this is the same as saying 10 to the 1, which if it's positive down here, that's a negative exponent. These are basically two ways of writing the same thing. Number 52 says 1 over 100. Now I can rewrite that as 1 over 10 squared, right? because 100 is 10 squared, which is the same as saying 10 to the power of negative 2. 10 to the power of negative 2 is the same as 1 over 10 to the power of 2. 53. 1 over 1,000. Okay, I want you to try to follow the pattern we did for 51 and 52 and see if you can finish that one, as well as 54. Try those on your own. Okay, question 55. Complete the pattern using powers of 5. So here we have 1 over 5 squared, and then 1 over 5 to the 1, then 1 over 5 to the 0, then 1 over 5 to the negative 1, and then 1 over 5 to the negative 2. Okay. And we're going to go ahead and simplify each of these. So this is going to be 1 over 5 squared. That's 25. Which I guess you could write. I think what they're looking for is this would be 5 to the power of negative 2. Let's go ahead and write it like that. I'm going to erase this. So you rewrite this as 5 to the power of negative 2. What would this one be? Well, this would be 5 to the power of negative 1. This one would be 5 to the 0, which is just 1. We know that. This one would be 5 to the 1, which is just 5. And this would be 5 to the 2. Okay, I think that's what they're looking for. Part B, write 1 over 5 to the negative 4 using positive exponent. So 1 over 5 to the negative 4. We want to write this using positive exponent. So notice it's in the denominator and it's a negative exponent. So it needs to move where it's at, making it a positive exponent, but on top. And there you go. All done. Let's go ahead and move to page 429. And we're going to look at question 8 to start. So it says rewrite each expression using each base only once. So it says for question 8, it says 7 to the power of 3 times 7 to the power of 4. So remember, when we're multiplying, as long as you have the same base here, what you do is you add the powers. So this is going to be 7 to the power of 3 plus 4, which is 7. Okay, which makes sense because what does this mean? 7 to the power of 3. Well, that means 7 times 7 times 7, right? Right, that's 7 to the power of 3. And then times, well, 7 to the power of 4, that's 7 times 7 times 7 times 7, right? Well, isn't this just the same as saying 7 times itself 7 times, right? So hopefully that makes sense why we add the powers there. Question 9. Here we have negative 6 to the power of 12 times negative 6 to the power of 5 times negative 6 to the power of 2. Okay. So this would be negative 6 to what power? Well, again, we have the same base, so when we're multiplying, we can just add those powers. So 12 plus 5 plus 2, that's 19. So this is the same as saying negative 6 to the power of 19. Question 10. Here we have 9 to the power of 6 times 9 to the power of negative 4 times 9 to the power of negative 2. So again, we want to add these powers, right? So 6, so it's going to be 9 to the power of 6 minus 4 minus 2. So when we add 6 plus negative 4 and then plus negative 2, that's the same as saying 6 minus 4 minus 2. All right, so what's that? What's 6 minus 4? Well, that's 2. 2 minus 2, that's 0. So this would be 9 to the power of 0. Well, what does that equal? Well, doesn't that equal to just 1? Yeah, that's right. Next one, number 11. 2 squared times 2 to the 7th power times 2 to the 0th power. Okay, well, once again, we have the same base, so we just add these powers. So this will be 2 to the power of 9. 2 plus 7 plus 0. Okay, don't make the mistake of multiplying these powers. That would not be correct. You want to add these powers. So when we're multiplying here, as long as we have the same base, we add the powers. Okay, I'm going to let you go ahead and try number 12 on your own and try number 13 on your own. Okay. Try number 14 on your own. Same thing. Okay. Number 15 says 5c to the 4th times c to the 6th. Okay. Well, this 5 has no one to multiply with, right? It just comes along. But if they both had coefficients, like if this was a 5 and this one had like some other number, like a 4, you'd multiply those together. Okay. But only the 5, and this is like a coefficient of 1. So if you multiply those together, it's still just 5. And then as far as the c's go, you're multiplying, so you add those powers together. So that's c to the power of 10. 16. 4t to the power of negative 5 times 2t to the negative 3. Okay. So again, we multiply those coefficients together. So 4 times 2, that's 8. And then we go ahead and add those powers, right? So that's going to be t to the power of, so what's negative 5 plus negative 3? Well, that's negative 8. If you want, you can rewrite this as 8 over t to the 8th. Again, when you move the negative power into the denominator, it becomes a positive power. 17. Here we have x to the power of 5, y to the power of 2, or in other words, y squared. Remember, to the power of 2, sometimes we'll just say y squared. That means the same as saying y to the power of 2. Those are the same idea, same thing. So I might use those interchangeably. Okay, and then we have x to the power of negative 6, and then just a y. So when this y is by itself, you can think of this as y to the power of 1. So once again, we want to add the powers, but you only add the ones that have the same base. So this x to the power of 5 and this x to the power of negative 6, we can add those powers together because they have the same base x. So then that would be 5 plus negative 6. That's x to the power of negative 1. And then what about the y's? Well, we add those powers. So 2 plus 1, that's y to the power of 3. Since you have a negative exponent here, a lot of times you want to rewrite that with a positive exponent by putting that in the denominator. Okay. In fact, you don't even need this 1 anymore because anything to the power of 1 is just itself. 18. 5x to the 5th times 3y to the 6th times 3x squared. Okay. So we can go ahead and multiply all the coefficients together. So 5 times 3 times 3. So 5 times 3 is 15. 15 times 3 is 45. So that's generally where I like to start, is by multiplying the coefficients together. Then we're going to have x to what power? Well, let's go and add the powers for the x's. So here we have a fifth power, and here we have a squared here. So that's going to be to the power of 7. Then we have y. Just that y to the 6 comes along, just like that. Question 20. Here's a word problem. So I'm going to go read aloud, and if you could just follow along, that'd be great. Biology. A human body contains about 2.7 times 10 to the fourth microliters of blood for each pound of body weight. Okay, so I'm going to write that number down. 2.7 times 10 to the 4. Okay. Now remember, hopefully you remember scientific notation. That fourth power means you'd move the decimal to the right 4 places to put it into standard form. Okay. Each microliter of blood contains about 7 times 10 to the fourth white blood cells. Okay. About how many white blood cells are in the body of a 140-pound person? Okay. So what we want to do here is we actually want to multiply this by the 7 times 10 to the fourth. 7 times 10 to the fourth. And then also multiply by 140. So 140 pounds, there's this many microliters per pound, and there's this many white blood cells per microliter. So we're going to multiply those together. Generally, when it's like this per that, you multiply those together to figure out how many, right? Okay. So what we do is multiply the coefficients together. So 140 times 2.7 times 7. So let's go ahead and do that. 140 times 2.7 times 7. So multiplying those coefficients, we get 2,646. And then we can say times 10 to the power of what? Well, notice these times 10s, they both have the same base 10. So we can add those powers together. To the power of 8. That's it. Question 21. Astronomy. The distance light travels in 1 second, in other words, 1 light second, is about 1.86 times 10 to the 5th miles. So I'm going to go ahead and write that down. 1.86 times 10 to the 5th miles. That's how far it travels in 1 second. That's a far distance. Saturn is about 475 light seconds from the sun. Okay. How many miles from the sun is Saturn? Okay, so we would just multiply this by 475. So here we would just multiply the 475 times the 1.86. Gives us 883.5. And then we'd say times 10 to the 5th. So this is how many miles away. That's a large distance, because remember, this times 10 to the 5th, we'd move the decimal 5 places to the right. 31. Complete each equation. So here we have 5 squared times 5 to the blank. They just got a blank spot. Equals 5 to the 11th power. Okay. So what they want you to see here is that, kind of what we were talking about earlier, is that we would add these powers together to get this, as long as they have the same base. So 2 plus what gives me 11. So what would have to go in this blank? Well, that would have to be a 9, wouldn't it? Right? 2 plus 9 is 11. So here we can just put like that, 9. Okay. That's what would go in the blank there. Okay, 32. Here we have m, and then the blank is here. M to the power of something times m to the power of -4 gives us m to the power of -9. So what power plus this -4 would give us -9? Well, that would be -5, right? -5 plus -4 gives us -9. So -5 is our answer for that blank. (33) 2 to the power of blank times 2 to the power of 1/2 equals 2 to the power of 1. So what plus 1/2 gives us 1? Well, this would have to be 1/2. 1/2 plus 1/2 is 1. So this would be 1/2 goes in that blank. Okay. Next one. A to the power of blank times a to the power of 4 equals 1. Okay, so now the trick here is that instead of a 1 here, you could think of this as a to the power of 0, right? Because a to the power of 0, that's 1. So what would have to go here in order for this to be 0? Well, that would be -4. Right? So a to the power of -4 times a to the power of +4, that would give us a to the power of 0, which is 1. So -4 goes in that blank. 35. A to the power of 2/3 times a to the power of blank equals a to the power of 5/6. Okay. So I'm just going to go ahead and show you basically what they're doing and show you with some of these examples we already did. So let's look at the first one we did, how we got this 5 to the power of 9. Well, couldn't have we had just taken the 11 here minus 2? That gives us 9, right? Or -9 minus -4 gives us -5. So that's kind of the trick here. And so we can do that here. So it'll be 5/6 minus 2/3, and that'll tell us what goes in that blank. Okay, so remember, when we're adding or subtracting fractions, we need a common denominator. So in this case, we need a common denominator. We're going to make it a denominator of 6. So this first fraction doesn't need to change, but the second fraction needs to multiply by 2 on both the denominator and numerator to change this into sixths. So that makes 4/6. 5/6 minus 4/6 is 1/6. So the answer is that 1/6 goes in this blank. Okay. Question 39. So here we're multiplying scientific notation stuff. So this first one is 9 times 10 to the power of 7 times 3 times 10 to the power of -16. So kind of the trick here is kind of what we already covered before, but you multiply the coefficients. So 9 times 3, that gives you 27. And then times 10 to the power of, and we add the powers, right? So 7 plus -16 is -9. Okay. Now it says to write our answer in scientific notation, and we are almost in scientific notation, but not quite. Remember, in scientific notation, we want instead of 27, we want it to be 2.7. Okay. So we need to move the decimal from where it's currently at into between the 2 and the 7. So it's currently at behind the 7. So we need to move it one more here, just like that. Okay. So when we move it to the left like that, that actually increases our power by 1. So times 10 to the negative 8. Okay. Notice I increased our power by 1, right? It went from negative 9, I add 1, that gives me negative 8. Okay. Number 40 is a similar idea. So we have 0.5 times 10 to the negative 6 times 0.3 times 10 to the power of negative 2. Go ahead and multiply the coefficients. So 0.5 times 0.3 is 0.15 times 10 to the power of, add the powers. So that's going to be negative 8. Now, I don't really want it like this. I want the decimal to be between the 1 and the 5. Basically, I want one number in front of the decimal. Here I don't. I just have like nothing in front of the decimal. So I'm going to need to move it 1 to the right. So that's going to be 1.5 times 10. Here we would have to decrease our power. So negative 9. I know this is a little tricky, but that's how it's done. Excuse me. You could always put both these in the calculator to make sure they give you the same answer as well. Okay, 42, chemistry. In chemistry, a mole is a unit of measure equal to 6.02 times 10 to the 23rd atoms. So 6.02 times 10 to the 23 atoms. This is a number you're going to see a lot if you ever take chemistry. If you ever take chemistry, you're going to know how many atoms are in a mole. You're going to have to memorize that number. The mass of a single neon atom is 3.35 times 10 to the negative 23 grams. What is the mass of 2 moles of neon? So here's 1 mole. This is the quantity of 1 mole. 2 moles, we'll have to multiply by 2. And the weight of a single neon atom is 3.35 times 10 to the negative 23rd. Okay, so let's go and multiply these together. So we'll have to multiply 2 times 6.02 times 3.35. Which is 40.334 times 10 to the power of what? Well, we want to add those powers together, right? So that's going to be to the power of 0, right? 23 plus negative 23 is 0. Well, 10 to the power of 0, well, that's just 1, isn't it? So we have 40.334 times 1, which is just 40.334. Okay. Let's go to the next set of problems on page 436 and through 438. Start on question number 10 here. Here, we're going to talk about a power to a power. So in this one's case, number 10, we have n to the power of 8, and then that is to the power of 4. So when you have a power to a power, what you do is you multiply those powers. So this is going to give us n to the power of 32, okay? Which should make sense because n to the power of 8 to the power of 4 would be n to the power of 8 times n to the power of 8 times n to the power of 8 times n to the power of 8, because there's 4 of them multiplied together. And what do I do with these 8s? Well, I would add those, right? And that's what gives me n to the 32, right? The shortcut is just to multiply. So when you see a power to a power, we multiply those powers. Okay, go ahead and try number 11 on your own. Number 14 here. Here we have w to the power of 7, and then to the power of -1. So power to a power, we want to multiply those. So that's going to be w to the power of -7, right? 7 times -1 is -7. So that's going to give us 1 over w to the 7th. We could write it like that as well. Number 22. Here we have 3 n to the -6, and then that's to the power of -4. So in this case, this -4 power would go to the 3 as well as to this n to the 6th. So we're going to have 3 to the power of -4, and then n to the 6th to the power of -4. Power to a power, we multiply those. So that's going to be n to the power of 24. Here, since we have this negative power on the 3, we could put that in the denominator and make it a positive power. And if we really want to simplify things, so this is n to the power of 24 over, what's 3 to the power of 4? Well, that means 3 times 3 times 3 times 3, that's 81. So n to the power of 24 over 81. Number 23. Here we have 7a to the power of -2. So this -2 would go both to the 7 and to the a. So this would be 7 to the power of -2, a to the power of -2. If we want to make those positive powers, we would put them in the denominator. So we have 7 squared times a squared. What's 7 squared, by the way? Well, that means 7 times 7, right? So that's 49. A squared. So 1 over 49a squared. Question 30. Oh, here. They're getting a little more complicated here, but not too bad. So 3b to the -2 times, and this gets a squared as well, a squared b to the 4th to the 3rd. Okay, so let's look at this first parentheses first. So first, everything in this parentheses gets a squared. So that's going to be 9, and then b to the -4, right? Because -2 times 2 is -4. Then this one, a squared to the power of 3, power to a power, you multiply those. So that's a to the 6th, and then b to the 12th. Now when we multiply these together, that's going to give us 9. It doesn't have anything to multiply with over here. The a doesn't have anything to combine with either. But the b's, since they have the same base, both base b, you could add those powers. So that's going to be b to the power of 8. Okay. Here you can put equal signs here. Okay. Question 31. So 31 says all kinds of stuff. So we have 4j squared k to the 6th times 2j to the 11th. This thing is to the power of 3, and then we have k to the 5th. So the first thing I want to look at is this parentheses here. So I'm going to go ahead and work out what that is. So first we have 2 to the power of 3. That means 2 times 2 times 2. Okay, well that's 8. And then j to the power of 11 to the power of 3, power to a power, we multiply those. So that's j to the power of 33. Let's just drop everything else that's coming along here. Okay. Now we can multiply all our whole numbers together. So we just have a 4 and an 8 multiplying together. So what's that? That's 32. Then we're going to have j to the power of what? Well, we can add this j squared with these 33 j's right here. So that's going to be j to the 35. Then k to the power of what? Well, we have 6 and then 5 more. That's 11 k's multiplied together. 34. Simplify. Write each answer in scientific notation. So here we have 3 times 10 to the 5th, and then this whole thing is to the power of 2. So this is going to be 3 to the power of 2. That's 9. And then times 10 to the power of, here we have a power to a power, so you multiply those powers. So 5 times 2 gives you 10. So this is 9 times 10 to the 10th. 35. Here we have 4 times 10 to the power of 2, so 10 squared, to the power of 5. So here we would do 4 to the power of 5. Well, what's that? That means 4 times 4 times 4 times 4 times 4. 4 to the power of 5 is 1024. Times 10 to the power of, power to a power, we multiply those. So we have 10 to the power of 10 now. We want to change this to scientific notation. Right now the decimal is right here, but we need to move it 1, 2, 3 places so that only a 1 is in front. So this is going to be 1.024 times 10. And if we had to move the decimal to the left, that adds to our power. So we're going to have to add 1, 2, 3 more to our power, making it times 10 to the 13. You could always put these both in the calculator and make sure you get the same answer. 36. Here we have 2 times 10 to the power of negative 10, and then this thing to the power of 3. So first 2 to the power of 3, that's 8. Because remember, that's 2 times 2 times 2. And then times 10 to the what power? Negative 30. Right? Negative 10 times 3 is negative 30. Here, this one's already in scientific notation because the decimal is behind the 8. Again, there's just one whole number in front of the decimal. That's how you know your correct scientific notation. Just like here, one number in front of the decimal. 43. Here we have b squared to the power of a blank. And we want to know what is in that blank to give us b to the power of 8. So here we have a power to a power. So these would multiply to give us this power. So 2 times what to get 8? Well, hopefully you know that that's 4, right? B squared to the power of 4 gives you b to the power of 8. So 4 goes in that blank. 50. Here we have 3x to the third, y to the blank, and then this thing to the power of the third equals 27x to the ninth. So the key thing here is that they want to show you that, like, hey, the y's got canceled, right, in the answer. So what would have to go here? Well, this would have to be to the power of 0, right? Because remember, y to the power of 0, that just is 1. And 1 times anything, that just cancels it and just goes away. So in this case, 0 goes in our blank. That's a little bit of a trick question, but 0 times 3 is, of course, 0. $51. Here we have m² squared n to the third to the power of blank equals 1 over m to the sixth n to the ninth. Okay. So one way to look at this, instead of looking at this as in the denominator, we could look at this as m to the power of -6 and n to the power of -9. So 2 times what would give me -6? Well, that would be -3, right? 2 times -3 gives me the -6, and 3 times -3 gives me the -9. So we know -3 goes in that blank right there. 66, part A. Next page. Says geography. Earth has a radius of about 6.4 times 10 to the 6th meters. What is the approximate surface area of Earth? Use the formula for the surface area of a sphere, which is surface area equals 4 pi r squared. Write your answer in scientific notation. So we're going to be using the formula for the surface area equals 4 pi r squared. So this is the surface area of a sphere, which of course the Earth is a sphere. It is not flat. And in our case, the radius r is 6.4 times 10 to the power of 6. So this is our radius. So we're going to plug that into the formula, replacing r with this radius. So that's 4 times pi times the radius, which in our case is 6.4, times 10 to the 6th, and then that thing gets squared, right? So now we have 4 times pi times, now this thing needs to get squared, so we'll do 6.4 squared, which is 40.96, and then times 10 to the, we have a power to a power, so that's going to be to the power of 12. Remember, power to a power, we multiply those powers. So now we can multiply 4 times pi times 40.96. And let's see. So that gave us roughly 514 point, and let's just go 2 decimal places. So we'll say 72, round to the nearest hundredth here. And then times 10 to the 12th. They want it in scientific notation, so we're actually going to have to move the decimal 2 times to the left. We only want a 5 in front of the decimal. So 5.1472 times 10 to the power of, since we moved to the left here, we're going to have to add 2 more to our exponent. So to the power 10 to the power of 14 here. (66b) says, oceans cover about 70% of the surface of Earth. About how many square meters of Earth's surface are covered in ocean water? Oh, by the way, this answer, since it's a surface area, this should be in squared meters. That's the type of measurement. Okay. So we want 70% of this. So how do we find 70% of a number? So essentially we're doing 70% of the surface area. So 70% of 5.1472 times 10 to the 14th. All right, so remember how to find a percentage of a number? We simply change the percentage to a decimal by moving the percentage twice to the left. So that's 0.70 of, we could change that to multiplication, so times 5.1472 times 10 to the 14th. So 5.1472 1472 times 0.7 gives us 3.60304 times 10 to the 14th. Okay, and again, that's squared meters. Okay, now let's move on to page 442. Okay. All right, I'm gonna stop recording here. I'll have to record this later. Finish the recording later.